There is a ball here. If we apply a force after it, what will happen to the object? It goes without saying that when you push an object, it's bound to move in the direction you pushed it. However, the British physicist Newton focused on acceleration. When you apply a force to an object, it doesn't just move, its speed increases rapidly. In other words, it gains acceleration. Based on experience, the following can be said about an object's acceleration. 1. Acceleration is proportional to the magnitude of the force, F, and is in the same direction as the force. If the force is doubled, the acceleration is doubled. If the force is tripled, the acceleration is tripled. It makes sense, right? After all, the harder you hit something, the faster and farther it goes. 2. Acceleration is inversely proportional to an object's mass, m. If the mass is doubled, the acceleration is halved. If the mass is tripled, the acceleration is reduced to 1/3. That makes sense, doesn't it? The heavier the object you hit, the slower it's likely to move when you strike it. Combining 1 and 2, we can express this as follows. Acceleration of an object equals F over m. Point. Force can be derived from the product of mass and acceleration. Find the acceleration of an object with a mass of 5.0 kilograms when a force of 10 N is applied to it. Substitute the values into the equations of motion to calculate the acceleration. Attach a light string to a smooth, lightweight pulley fixed to the ceiling. Tie objects A and B, with masses m and m respectively, to the ends of the string, and release them gently. Let g be the acceleration due to gravity. Find the magnitude of the acceleration of A and B, and the tension T in the string. Assume that m greater than m. How to set up general equations of motion 1. Define the direction of motion as plus, and assign an acceleration a. 2. List all the forces acting on the object of interest, gravity plus contact forces. 3. Ma equals sum all forces parallel to the acceleration a. 1. Let's define the direction of motion as plus, and write down the acceleration a. Let's write down the forces acting on the object of interest, gravity plus contact forces. 3. Add up all the forces parallel to the acceleration a. The direction of a force is indicated by its sign. For example, if we look at A, the gravitational force mg is directed downward, so it's plus, and the tension T is directed upward, so its equations 1 and 2 form a system of equations involving acceleration A and the tension T in the string. First, let's add the corresponding sides to find the acceleration A. Combining 1 and 2 yields the following equation. Also, 2 from this, let T equals mg plus ma, and substitute the acceleration A into this equation.